Hello everyone, we are starting system of particles and rotational motion. When an object is moving in a straight line, all parts of the object they are moving together. For example, if you imagine a car moving on a road, all parts of the car they are moving together very similarly. But then if you imagine the wheels of that car, the wheels are rotating, they are turning. In addition to turning, they are also moving forward. So when something is turning, part of it is moving forward, part of it is moving backwards. So rotational motion is slightly different compared to normal ordinary motion or straight line motion. In rotational motion, particles are essentially performing circular motion, but around a point that's called as the axis of rotation. So that's going into a lot of detail in this chapter, but basically try to understand this that when an object is rotating, different parts of the object are moving differently. For example, when the fan is rotating, the middle part of the fan is at rest, whereas the blades of the fan they are moving pretty fast. The tip of the blades are moving really very fast. So we can understand an object as a bunch of particles, as a bunch of different points containing mass. So this chapter is two parts. The first part of this chapter is system of particles. Okay. So we talk about a few things. We talk about moment of inertia, which is an idea that expresses the mass of an object but applied to rotational motion. Okay, we talk about moment of inertia. We apply moment of inertia to a few different objects. For example, we apply moment of inertia to a rod. We'll apply moment of inertia to a ring. We'll apply moment of inertia to a ball. Okay, you'll apply moment of inertia to a ball, probably to a plate, a rectangular plate. So we'll apply moment of inertia to a few different objects. Moment of inertia is used to write different equations in rotational motion and to find out the acceleration of an object. So to do all of that, you first of all try to understand how to express the mass of an object, but when it is rotating. You'll also see that the size of rotation matters. There is something called as axis of rotation, all of these concepts. After that is done, we come to the second part of this chapter, which talks about different concepts like we talk about torque, we'll talk about angular acceleration. You might have already studied angular acceleration when you were studying circular motion. We'll talk about a concept that's called as angular momentum. Angular momentum is the momentum a rotating object has. So the momentum a moving object has, an object moving in a straight line, that's called as linear momentum. When an object is rotating, the momentum it has is called as angular momentum. Okay, we'll talk about angular momentum. We'll try to solve some problems based on torque and angular momentum. We'll also have rotational collisions, okay, collisions between objects that involve rotation. So I call that thing rotational collisions. People just normally call it as collisions. And then finally, towards the end of this chapter, you'll study about toppling motion. And we'll do a few problems based on all the concepts in this chapter put together. So this is roughly the plan of this chapter. You'll require close to 9 lectures. Though I've written 6 topics, you'll require close to 9 lectures to cover this chapter, including all mains and advanced topics. Today we are starting over here and a few basic concepts like what is rotation. So first of all, what is rotation and what is translation? There are two different things. There is rotation and then there is also translation. Straight line motion and curvilinear motion, two different kinds of motion. So let's try to understand that. Imagine that you have a ball. Okay, so if you take a ball and you throw this ball in a straight line, or even if you throw this ball up so that the ball moves in kind of a parabolic path. Okay, so the ball goes up and it falls down. In all of these kinds of motion, the center of mass of this ball, or the midpoint of this ball, or even all the particles of this ball, they are moving by almost the same amount. They are moving together. All of the ball is moving similarly. So that's why I've drawn a few different arrows. Any particle you take on this ball is going to follow this entire path. It's going to go up and it is also going to come down. This is one kind of motion. Okay, so you take a block, you put it on the floor, and then you make this block move in a straight line. Probably you kick this block. Okay, so you give this block a kick, and this block starts moving in a straight line on the floor. So all particles of this block they mostly move by the same amount. So this particle is going to move that much. I mean, it's going to move a little bit forward. The particle is over here. This particle over here is going to move by this amount. So all particles of this block, this one is going to move by the same. All of these particles on the block, they are going to move by the same distance, or they are going to move in exactly the same way. So this kind of motion is basically called as translational motion. Even though the motion may not be along a straight line, different parts of the object move exactly the same way. When you're throwing a ball in projectile motion, when you're asking a block, like you're kicking a block and it's sliding on the floor. All these kinds of motion, they are called as translational motion. Okay, so this is called as translation. You've also studied about a kind of motion that's called as circular motion. So what is circular motion? You have a point, you tie a ball to that point, and then you rotate this ball in a circle. So this ball starts rotating in a circle. So this kind of motion is called as circular motion because that's basically one object and it's moving in a circular path. So you call this thing circular motion. Now imagine that instead of this single ball, I take a bat or I take some irregularly shaped object and I place it over here. Let's say I take a bat. Okay. So I take a bat and I swing this bat in a circle. So this is a bat and I'm swinging this bat in a circle. You can say that the bat is performing circular motion. That is kind of a very correct thing to say. But understand that different parts of this bat are moving by different amounts. So the handle of this bat is performing a small circular rotation. The body of this bat is performing a slightly larger circular rotation, and the tip of this bat is performing a different circular rotation. So the idea over here is different parts of the object are moving differently. If you take the handle is moving very less. The center point of this bat over here, it's not moving at all, it's absolutely at rest. And as you move far away from this point, the different parts of the bat are moving in different circles or along different paths. They're moving at different speeds. So this is the idea of rotational motion. So whenever something is performing rotational motion, the different parts of that object are moving by different amounts. This will make a lot of sense to you. If you put a pen on the table, okay, so you take a pen and you put the pen on the table, and then you start pushing the pen by different amounts. So you push the tip of the pen by, let's say, 5 centimeters, and then you push the bottom part of this pen by, let us say, 8 centimeters. So what's going to happen? This entire pen of yours is going to end up like this. So how did it end up this way? Because you move different parts of the pen by different amounts. The tip of the pen moved by 5 centimeters. The bottom part of the pen moved by 8 centimeters. So this pen basically went around, it turned around. It obviously moved forward. This pen did two things. It moved forward. So this part of the motion is called as translation. And the pen also did not end up like this. The expected thing was the pen should have ended up like this. We wanted the pen to look like this. So if the pen was in this way, then that would have been translation. But compared to this pen also rotated backwards. This pen also went backwards, and this part of the pen went a little bit forward. So this part of the motion is called as rotation. Okay, so this is called as rotational motion. समझ में आया? So whenever something is undergoing rotational motion, different parts of the object, they are moving by different amounts. And you just can't summarize it as circular motion because if you see the tip of this pen has moved by a pretty large amount. Okay, the bottom of this pen is moved by a pretty large amount, whereas the middle part of this pen is exactly where it was expected. So this part is not moved at all. It moved by the exact same amount that it was expected of it. So different parts of the object, stating this once again, different parts of the object, different parts of the object move differently, move differently. I'm not saying they move in a very random motion. I'm just saying the amount of motion they cover or the amount of distance they cover is different. So the edge of the object is going to move a lot. The center part of the object is not going to move so much. Different parts of the object are moving differently. Such kind of motion is called as rotational motion. Keep in mind, whenever something is performing rotational motion, there is going to be something called as the axis of rotation. Okay, there is something that is called as the axis of rotation. Basically, the axis of rotation is a straight line that passes through a point, like in this case, the middle part of this pen, but the point should stay at rest. That's the basic requirement. It's a straight line that passes through a point, and that point should be at rest. Even the point can move like at constant velocity. So, axis of motion, like for example, in a car, if you think about a car, then the axle of the wheels is the axis of rotation. If you talk about a car and the car is moving on a straight road, these are the wheels of the car. Then the wheels of the car are rotating. All of these wheels of the car, they are performing rotational motion. And because of performing rotational motion on the road, the entire car is moving forward. So along with the car, the body of the car, the axle of the car, they are also moving forward. So the axis of rotation doesn't need to be absolutely at rest. I'm just saying relative to different parts of the object. Okay, so one part of the object is moving forward, this part of the object is moving backward. In that sense, this part is not rotating at all. So your axis of rotation shouldn't start rotating with the object. It should stay at rest. But defining it like that tries to exclude some problems. So instead of going into all the complicated aspects of what exactly defines an axis of rotation, try to understand it on a basic level. For example, when you're opening a door, okay, when you have a door and you're opening the door, like for example, let's draw a door over here. This is a door, and these are the hinges of the door over here. So this is the hinge, this is the hinge. You take the handle of the door and you swing the door open. So when the door is swinging open, all the points on this line of the door, they are not moving. All of these points, they are at rest. So this line over here, passing through all of these points that is at rest, is called as the axis of rotation of that door. Now, I'm not denying the fact that this door could be a door on a bus. The bus is already moving. So, all these points are not technically at rest. They are not. But when the door is rotating, these points are not rotating with that door. So, in that sense, this line is the axis of rotation of this door. Okay, so I'm not going to define axis of rotation in like one sentence or something, but if you try to read a book, so in those in those things they normally say that axis of rotation passes through a point that is at rest with respect to rest of the object. The rest of the object is rotating. These points in the object, they tend to stay at rest. So this is the axis of rotation. The rest of the object, it rotates about the axis of rotation. So it rotates about the axis of rotation. Now, see, there is something also called as the instantaneous axis of rotation. We'll talk about it in a different class. So, when an object is performing translational motion, rotational motion, all different kinds of motion, some part of the object may be at rest for a very small amount of time. So, a line passing through such a point that is staying at rest for a very small amount of time is called as the instantaneous axis of rotation. For example, imagine somebody who is running on the ground. So when the feet touches the ground and the person is moving forward, the rest of the body is rotating about that point of contact if his leg doesn't slip. So that point of contact is called as the axis of rotation. When the wheels of a car are rotating, if the wheel is not slipping, the part of the wheel that's in contact with the road is at rest. So a line passing through that point is also an axis of rotation, but it is called as the instantaneous axis of rotation. So right now you're studying this chapter for the first time. Focus about two things. The first thing is what is the idea of rotation? I hope you have already gotten it by now. Whenever an object is moving, there are two ways the object can move. Either all of the object can move together. Imagine a block sliding on the floor. Imagine a truck moving on the road. All of the object is moving in exactly the same way. Or different parts of the object can start moving differently. Such kind of a motion is called as rotational motion. Whenever an object is performing rotational motion, there is something that is called as the axis of rotation. Okay? There is something that is called as the axis of rotation. It basically passes through a point that stays at rest. Just to clarify one thing, the axis of rotation could pass through any point. So that point can either belong to the object, like in the case of the door, the point belongs to the hinges of the door. It could also belong to a point, or it could be located at a point that is far outside the object. For example, if you take a funnel and then you make a ball roll inside this funnel pretty fast, then this ball is rotating in a circular path. It's kind of performing circular motion, but it's also rotating, and the axis of rotation is about the center of this funnel. So it is not essential that the axis of rotation should pass through the body. It can pass outside the object as well. Just like the center of mass of an object can be outside the object, the axis of rotation could be any point. Either it could be part of the object, it's normally a part of the object, it could be the middle point of an object, it could be the edge of an object, it could even lie outside the object. So the axis of rotation could be any point, but the requirement is that point should not itself rotate or accelerate, or normally the point should stay at rest. The point can move, it can have some kind of velocity, but preferably it should stay at rest while solving a problem. That's not a requirement. Okay? So this is the first part of the chapter. There are two kinds of motion. There is translational motion, there is rotational motion. Rotational motion is when different parts of the object are moving differently. Okay, next idea in this chapter. The next idea is something that is called as moment of inertia. So before we talk about that, let's talk about inertia. Inertia is another name for the mass of an object. Okay, so whenever something is moving, then you know that that object has momentum, it has kinetic energy, there is kinetic energy, there is momentum. We'll talk about kinetic energy right now because it's easier to understand. It's scalar quantity. So, for example, if you take a ball, okay, you take a ball and the ball is rolling on the floor with a speed of v. What is the kinetic energy of this ball? The kinetic energy of this ball is equal to half. If the mass of the ball is equal to m, then it is equal to half into m into v square. Okay? This is the kinetic energy of the ball. Or basically, this is the amount of energy that the ball has because it is rolling on the floor. Now you take the exact same ball and you tie it to an axis, or you tie it to a pole with a rope. Now you make this ball start rotating in a circle. Okay, this ball is rotating in a circular path. Let us still say that the velocity of the ball is equal to v. So it is moving around a circular path with a speed of v. So at different points, the speed is going to change its direction, but the value is equal to v everywhere. Let's say the radius of this circle is equal to r. What is the kinetic energy of the ball? Obviously, the kinetic energy of the ball is still equal to half mv square. But right now, because it is moving in a circular path, we have a new quantity that we can define, and we call that thing angular velocity, omega, the rate at which it is rotating, the speed of rotation. So you can write v is equal to r omega. Why can you write this? Because the object is performing circular motion. I told you rotational motion is very similar to circular motion, except it is for a larger object. So right now, just for simplicity, we have taken a very small object. So here rotational motion and circular motion are basically identical to each other. So V is equal to R omega. Instead of writing V square, I can now write half M. Instead of V, I can write R square omega square. Okay? The omega is the rate at which the object is rotating or the object is moving in a circle. So that is the rate of rotation. So just like we wrote m and v square, the v is the velocity at which it is translating, omega is the velocity at which it is rotating. So it is called as the angular velocity of an object or the rotational velocity of an object. This is called as angular velocity. So this remaining part in the middle, this mr square part over here, is called as the moment of inertia of this object. So we can write half into I into omega square. So while first of all, we are studying something that the rotational kinetic energy is equal to half omega square. Just like translational kinetic energy is equal to half mv square, rotational kinetic energy is equal to half I omega square. I've written T for translation and R for rotation. So I over here, which is equal to mr square, is basically what is called as the moment of inertia. So it is just basically a way of talking about the fact that different parts of the object are moving differently. Here the object is not moving in a straight line. The parts that are closer to the axis, the parts that are far away from the axis, they are all moving differently. So we just say, we summarize the entire object over here by saying that the object is moving in a circular path, and that is why the kinetic energy is equal to half into I into omega square. We are writing the same thing, but in a different way. So this lets us solve problems on rotational motion. So the first new thing for you, there is something called as moment of inertia. Moment of inertia. So what does moment of inertia do? Moment of inertia basically is a representation of mass, but in rotational motion. How do you define moment of inertia? To define moment of inertia, you first of all need to define an axis of rotation, a point in the object or near an object that stays at rest when the object is rotating. So once that is done, you take your object. My object is a very small ball, so this thing is called as a point mass right now. because the size of the object, its own rotation doesn't matter. All that matters is this object is going around this axis in a circle. So this is a point mass. There are other kinds of masses. There is a ring, there is a rod. The shape of the mass is also going to matter. Here the shape doesn't matter, so I'm just calling it a point mass. Now you take the distance from the axis. The distance from the axis. The distance should be perpendicular to the axis. So you take the perpendicular distance from the axis, perpendicular distance from axis of rotation. Okay? And then you take the mass of the object, m. So for a point mass, the moment of inertia for a point mass can be written as m into r square, mr square. The moment of inertia for a point mass is mr square. What if this object was not a point mass? What if this object was some irregularly shaped kind of an object? The moment of inertia of such an object will not be equal to mr square. But still some properties are going to carry over. First of all, moment of inertia will depend upon the mass of the object. So if you take a heavier object, the moment of inertia is going to be more. And the second thing, it will still depend upon the distance from the axis of rotation. But in this case, the distance will be of different points on the object. So it is going to depend on r, but the r is going to be of several different points in this object. So we'll have to manually calculate what is the moment of inertia by adding for all these points. So we can say that each of these points in the object is a point mass. For example, you can imagine a bag full of sand, or you can imagine a bag full of rocks. Each of the rocks is a point mass. It is a small point that has mass, so it's a point mass. And each of those points is going to have a different distance from the axis, which you can call as r. So for all of them, you can say that the moment of inertia of point A is equal to ma ra square. The moment of inertia of point B is equal to mb rb square. So all of this A, B, C, D, together they will form your entire object. To find out the total moment of inertia, the net moment of inertia, you will have to add up all the individual parts. So we will write I, so where I is the index, like 1, 2, 3, 4, and then the distance from the axis of rotation for all of those, and then square. समझ में आया? If you have an axis of rotation, if you have a point mass, the moment of inertia is very simple. For a point mass, the moment of inertia is equal to mr square. What if you have an extended object? You have a randomly shaped extended object. Then you don't have a point mass. So what you will do is you will take different points in this object, and you will say that this object is an extended object. What is this object? It is an extended object. So therefore, this object is made up of many points, many different points. So each of this point or each of this particle, many different points, you can also call it particles. So each of these particles has a different distance from the axis. So if you take the ith particle, the distance from the axis will be Ri and its mass will be Mi. Now you can take the mass of all of these particles the same. That's not a problem. You can take the masses to be different. That's up to you. But each particle is going to have its own moment of inertia, Mi Ri squared. What is R? Perpendicular distance from the axis of rotation. What is the net moment of inertia? That is the sum. I hope you understand this sign. This sign is sigma sum. So mi ri square. That's the moment of inertia of an extended object. So this doesn't give you an answer. This formula basically gives you a way to find out the moment of inertia of an object. So first of all, we'll do a couple of problems based on point masses. Okay. What is difference between point mass and an extended object? In a point mass, most of the mass has the same distance from the axis of rotation. There is no like extension. This object is a very small ball and the axis of rotation is a line. So you can clearly define r and then you can write mr square. What is an extended object? Some parts of the object are very near. Some parts of the object are very far. Different parts are at different distances. So that's an extended object. Okay, understood? Let's do some problems on point masses and then we'll go for extended objects. First of all, let's start with a basic problem. Let us say that there are two masses. Okay, so let's say that there are two masses, one of 50 grams and one of 100 grams. There are two masses, one of 50 grams and one of 100 grams. So it's kind of like a dumbbell, one of 50 grams, one of 100 grams. They are placed in a straight line connected by a very thin rod. and you take the midpoint of this rod. Okay, you take the midpoint of this rod and then you rotate the entire system. So this 50-gram mass is going to move in a circle. It's going to move like this. The 100-gram mass is also going to move in a circle. It's going to move like that. Okay? So you take this particle, you take this rod, and you move it in a circle. You rotate it with some angular velocity omega. That doesn't matter. These distances are given to you as 20 centimeter, and that distance is also given to you as 20 centimeter. What is the moment of inertia of this system? What is the moment of inertia of this system? What is the value of I? That's your first problem today. So key thing is, if this 100-gram mass was not present, if this 100-gram mass over here was not present, then I would only have one particle. I would have this left particle A. I've removed the right one B for now. So the moment of inertia of my left particle would be equal to how much? M into R squared. So basically MA RA squared, mass of A, distance of A squared. So what is distance of A? 20 centimeters. What is mass of A? 50 grams. So you will write mass of A 50 grams. So you have to convert that into kgs, SI units, multiplied by radius of A squared. So what is the radius of A? Which is equal to 20 centimeters. Radius matlab distance from the axis. It's moving in a circular path, distance from the axis. So 20 divided by 100 squared. That is the moment of inertia. What is its value? So you can calculate 50 divided by 1000 multiplied by 2 divided by 10 squared. So basically that is 4 divided by 100. So 50 into 4 is equal to 200 divided by 1000 into 100. So you can cancel that. The value is equal to 0.002. Okay? I am getting 0.002. Okay. Now let's put the mass B back. What was the mass of B? 100 grams. Let's now forget that A was present. Okay. Let's for a moment forget that there is A. So if only B was present, I could write IB is equal to MB RB squared. I would write mass of B is equal to 1000 grams, and then I would write the distance of B from the axis, which is equal to RB. This is the mass of B, and that is the distance of B from the axis. That's 20 centimeters squared. So 20 divided by 100 squared. कितना हो जाएगा? 100 divided by 1000 multiplied by 2 by 10 का square, which is equal to 4 divided by 100. So I'll get 0.004. The point here is, I have both of these together. I have A and I also have B. So this is the thing with moment of inertia. If axis of rotation is same, if axis of rotation is same, if the axis of rotation is same for two objects, then the moment of inertia can be added. The moment of inertia can be added. ठीक है, सबसे पहली बात तो what is the first idea that we utilized the formula itself. So you learned how to do this, m into r squared. What is the unit? The unit of mass is kg, the unit of radius is meter, so the unit of moment of inertia is kg meter square. There is no name for this. The unit of moment of inertia is just kg meter square. So this is 0.02 kg meter square, that is 0.004 kg meter square. The next thing is, if there is more than one object, for example, there is B over here and there is A over here. There are two objects over here. So how do you find the moment of inertia of a system where there are two objects? So if there is more than one object, if there are two objects or if there are three objects, four or even n number of objects, you can add the moment of inertia provided that the axis of rotation is the same. So in this case, I can write I net is equal to IA plus IB. क्यों? क्योंकि दोनों का axis of rotation same है. Even for the green one, the axis of rotation is the middle one. This is the axis of rotation for the green thing. And even for the blue thing, the axis of rotation is still the same. This is the same line that is the axis of rotation for A. So for A as well as for B, the axis of rotation is the same. You can add up the moment of inertia. You can write 0.002 plus 0.004 is equal to 0.006 kg meter square. समझ में आया? So moment of inertia क्या होता है? mr square होता है. When do you add moment of inertia? Moment of inertia can be added if the axis of rotation is the same. Okay. So to see if you understood this problem, first of all, you should try this on your own. एक बार खुद से करके देखो. Keep in mind that mass is in kgs. Mass is not in grams. Sometimes you'll be given mass in grams. So remember to convert it into kgs or your moment of inertia value is going to be wrong. Radius is going to be in meters. It's never in centimeters. It can be given to you in centimeters, convert to meters. Always write your values in SI units. And once you're done calculating, keep in mind that moment of inertia has a few different properties. One of the properties of moment of inertia is that it is not a constant. I'll write it over here. Moment of inertia is not a constant. The moment of inertia of an object is not a constant. What does that mean? The mass of an object is a constant. If I go to the market and I get 3 kg of apples, that is 3 kg of apples. But the moment of inertia is not a constant because it depends on the axis of rotation. Because it depends on the axis of rotation. You can try this if you have a rotating chair at home or wherever you see a rotating chair. Try to put a finger on the chair and try to spin it. You can very easily spin the chair by putting a finger on the seat and just trying to spin the chair. You can do that. But if you try to hold the arms of that chair, जिस पे अपन हाथ रखते हैं, if you try to hold the arms of that chair and then you try to rotate it, rotating the chair is going to be very difficult. You can't rotate the chair around you. You can rotate that chair at one point on its stand very easily, but rotating it around you is going to be an entirely different story. It's going to be pretty hard. So keep in mind, moment of inertia of an object is not a constant quantity. It is a variable. It depends on the axis of rotation. So for different axes of rotation, the same object can have different moments of inertia. All of us have phones. So don't drop your phone, but you can try doing this. You can hold the middle part of your phone and you can try spinning it. It's going to be easy. But if you hold the edges of your phone and then you try spinning it, you'll suddenly feel as if the phone is heavy. So moment of inertia of an object is different for different axes of rotation. ठीक है इस चीज को समझो. Then let's go for the next problem. Let us say that there are two particles of mass 1 kg. Two particles of mass 1 kg are placed. Two particles of mass 1 kg are placed at 3, 4. ठीक है, there are two particles of mass 1 kg each. They are placed at 3, 4 and 1, 2. All of these are in meters. So this is 3 meters, 4 meters, 1 meter, 2 meters. So what does that mean? That means that you have an XY coordinate system. There is the y-axis, there is the x-axis, and you're placing two particles at 3, 4. So let's just draw 1, 2, 3, 4. 1, 2, 3, 4. Two particles are placed at 3, 4. So one particle is placed over here and the other particle, this is 3, 4, and the other particle is placed at 1, 2. So you're placing one particle over here. Okay, there are two of these particles. Let's call this A and let's call this B. So this particle is A and that particle is B. Try to find out the moment of inertia if these particles are rotated about the y-axis. First question. Find the moment of inertia. Find the moment of inertia if the particles are rotated about y-axis. Try to do this on your own. ठीक है इसको खुद से करो. You're watching this video, try to pause this at this moment and then try to do this problem on your own. I'll tell you the answer. If you've already solved it by now, fine. Notice that the axis of rotation is the y-axis. So this is your axis of rotation. This one is your axis of rotation. You have to take the perpendicular distance from the axis of rotation. So this is the distance that you have to take. Perpendicular distance from the axis of rotation. This is R. So this is RA and that is RB. What is RB? RB is just equal to 1. So RB is equal to 1. What is RA? RA is equal to 3. तो फाइंड आउट द मोमेंट ऑफ इनर्शिया ऑफ द फर्स्ट ऑब्जेक्ट. ए का पहले मोमेंट ऑफ इनर्शिया निकालो. आई ए इज इक्वल टू मास ऑफ ए into distance of a from the axis squared, not radius of a, distance of a from the axis. R means distance from the axis. So distance from the axis squared. So mass of a कितना है? Both objects are of mass 1 kg. What is the distance of a from the axis? The distance of a is equal to 3. So 3 squared. The moment of inertia is equal to 9 kg meter square. Okay. For B, now you calculate for B. The axis of rotation is the same, it is the y-axis. So for B, you can write mb rb squared. What is the mass of B? The mass of B is equal to 1 kg, so 1. Distance of B from the axis is equal to 1 meter, so 1 square. And that is equal to 1 kg meter square. Because the axis of rotation is the same. Because axis of rotation is same for both objects. Axis of rotation is same for both objects. You can directly add the moment of inertia. You can write I net is equal to IA plus IB. दोनों को अपन directly add कर सकते हैं. And you can write I net is equal to 9 plus 1 10 kg meter square. समझ में आया? The moment of inertia of this system about the y-axis is equal to 10 kg meter square. ठीक है? Understood? Now let's try to find out the moment of inertia of this system about the x-axis. इसी same system के लिए अपन moment of inertia निकालते हैं about the x-axis. So at this moment you can pause the video. You can try to do this on your own. So once you're done, play it and then you can see my solution to it. Keep in mind, when you're trying to find out about the x-axis, the axis of rotation is different. Always measure the distance from the axis of rotation, perpendicular distance from the axis of rotation. So now our axis of rotation is x-axis. तो हमें अपना perpendicular distance measure करना है x-axis. इस चीज का ध्यान रखो. Pause the video and try to solve it. So I hope you tried solving this on your own. See, my axis of rotation is the x-axis. So what I'll do is I'll measure the distances from the x-axis. So this is the distance I need. This is RB measured from the axis of rotation. So my axis of rotation is x-axis. So my object is rotating around this. So B is going to go in a circle, A is going to go in this circle. That is the axis of rotation. Okay, so this is RB and I'll measure RA as distance from the axis. This is RA. What is the value of RA? RA is equal to 4. What is the value of RB? RB is equal to 2. See, RB is equal to 2. In exactly the same way that we did before, you'll calculate IA. IA is equal to mass of A into distance of A from the axis squared. Mass of A is 1 kg, distance of A is equal to 4 squared, which makes it 16 kg meter square. Calculate IB. IB is equal to MB RB squared. Mass of B 1 kg. Distance of B from the axis, which is equal to 2 meters squared. That is 4 kg meter square. So what is the net moment of inertia? The net moment of inertia is equal to IA plus IB. तो IA plus IB कितना हो जाएगा? 16 plus 4 is equal to 20 kg meter square. तो ये तुम्हारा net moment of inertia है from the x-axis. So from the y-axis, if you remember, if you've just solved the problem, you might remember that the moment of inertia on the y-axis, I net y-axis, was equal to 10 kg meter square. So if the axis of rotation changes, the moment of inertia of a system of particles can change. So this is what I was saying. The moment of inertia is not a constant. For different particles, if you change the axis of rotation, the distance from the axis is going to change. And that is why the moment of inertia of those particles is going to simply change. Okay, let's try another problem. Try this thing on your own and then you can watch my solution to it. Let us say that there are two particles. Again, there are two particles on a straight line. This particle has a mass of m. That particle also has a mass of m. And we want to find out the moment of inertia about two different points. Okay? First of all, about the midpoint, where this distance is equal to L, that distance is equal to L. Find the moment of inertia about the midpoint of this line joining the particles. That is the first part. The second part is find the moment of inertia about this point where this distance is equal to L by 2 and the remaining distance is equal to 3L by 2. So first of all, try this. Then you can watch my solution as well. Find the moment of inertia. There are two parts to this question, part A and part B. Find the moment of inertia. Find I about, first of all, point A and then about point B. Okay, pause it right now, solve it on your own. What I would do is I would name these particles, let's say 1 and 2. Moment of inertia of particle 1 about axis A. So right now forget about axis B and forget about all the distances from axis B. So moment of inertia is mass of the particle, mass of 1, distance of 1 from the axis squared. The mass of 1 is m, distance of 1 from the axis is L, so m into L squared, which is equal to ml squared. Mass of the second particle, which is equal to m, distance of the second particle, which is equal to L, so m into L squared, that is again equal to ml squared. The net moment of inertia, because the axis of rotation is the same, we are taking both of this about axis A, then you can write the net moment of inertia is equal to 2 ml square, 2 ml square. Okay, so that solves it about A. What is the moment of inertia about axis B? So right now you can forget about axis A and all the distances that are given for the point A, forget about all of it. Now you take axis B. Axis B is at a distance of L by 2. This is axis B. So this distance is equal to L by 2. That remaining distance is equal to 3L by 2. Calculate once again. Moment of inertia of the first particle is equal to m into L by 2 squared, which is equal to ml square divided by 4. Moment of inertia of the second particle is equal to m into 3L divided by 2 squared, which is 9ml square divided by 4. Again, since the axis of rotation is B, you can write the net moment of inertia is equal to 9 ml square by 4 plus ml square by 4, which makes it 10 ml square by 4. Okay, simple. That's the first part of the question. Now try the second part. Find IB minus IA. Just find it. I'm asking you to simply subtract the moment of inertia. Find IB minus IA. How much is it going to be? 10 ml square divided by 4 minus 2 ml square. So 10 minus 8 is equal to 2. So it will be 2 ml square by 4, which is equal to ml square divided by 2. Okay, so later on I'll show you how this thing comes from a theorem that's called as the parallel axis theorem. But right now it doesn't matter. First of all, understand that if you change the axis of rotation, the moment of inertia is going to change. I've given you a couple of problems. This is, I think, your third problem today. ये तीसरा प्रॉब्लम है इसके पहले वाला जो प्रॉब्लम था दैट्स योर सेकंड प्रॉब्लम. Let's try to find out the moment of inertia of what is called as an extended object. So we are moving ahead. Next topic is extended objects. Objects that are not points. Extended objects. Basically, an extended object is a collection of point objects. But the point should not be distinct. Like you cannot take one mass at 1 meter, the next mass at 2 meter. The point should be together. A collection of point objects is called as an extended object. So you cannot take one point here like that, and you cannot draw a dotted line, and you cannot call it an extended object. Extended objects are like rods, rings. First extended object we'll study about today is a rod. Another extended object is a ring. Okay, you can take a ring. You could take a disc, like for example a biscuit, that's a disc. Okay, you could take a shell. An empty ball is a shell. You could take a solid sphere. Okay, you could take a solid sphere. You can take a cylinder. All of these are extended objects. So this is what we mean by an extended object, a proper solid object, not a bunch of points. But we can model any extended object as a collection of points, and then we can use that same property of moment of inertia. I is equal to summation mr square. So we'll use this property to find out the moment of inertia of these objects. ठीक है, सबसे पहले समझो extended object क्या होता है. A square plate is also an extended object. A triangular plate is an extended object, like for example a flag. That's an extended object. All of these are extended objects. We'll be modeling it as a collection of point objects, and we'll be finding out its moment of inertia. Okay. So today I am aiming to do two of these, rod and ring. In the next class, we'll try to derive for all the other shapes as well. First of all, let's start with a rod. The moment of inertia of a rod. The moment of inertia of a rod. Keep in mind the axis of rotation matters. So when I'm drawing this rod, My axis of rotation initially, right now, is the midpoint of this rod. I'm taking the center of mass, the midpoint of this rod, and I'm finding out the moment of inertia about this midpoint. ठीक है, later on we'll take one edge of the rod and also find out its moment of inertia. तो पहले midpoint को लेते हैं. Let's learn the technique of how to find out moment of inertia. See, first of all, this object, this rod, is made up of so many different points. You could take every small slice of this rod. Think about taking a carrot and slicing it up. So every small part of this rod is a very small mass. It's a point mass. You can take this rod and you can cut it into very small parts like I'm doing on the screen. I don't have the patience to slice up the entire left part as well. But what you can do is you can take a very small part of this rod, a very small slice of this rod, and you can call that as a point mass. Such a mass is called as a mass element. Okay? It's called as a mass element, dm. If the entire mass of the rod is m, if the entire length of the rod is equal to L, so this is a very small mass element, dm. So what is its length going to be? Dm matlab part of m, differential. So what is its length going to be? Its length is going to be dl. So keep in mind the mass depends upon the length of the rod. Longer rods will have greater amount of mass. So the mass divided by the length should be the same. It should be dm by dl as well. So you can say that dm is equal to m by l dl. Okay, you can write this. By the way, m by l has a name for it. This is called as mass per unit length, also known as linear mass density. ठीक है, इसको हम लोग linear mass density भी कहते हैं, but that is not essential to understanding rotational motion. So right now, it's not required of you that you understand this concept straight away. Mass per unit length is also called as linear mass density. ठीक है, तो सबसे पहला चीज dm is equal to m by l dl. Now, different parts of this rod, they are going to be at different distances. So my part is at a distance of x. Another part, the x value is going to be different. So every part of this rod, we can write it as dl, but by adding dl, you are changing x. So basically dl is equal to dx. तुम अगर एक एक स्लाइस ऐड करते जाओगे तो रॉड का लेंथ इंक्रीज होता जाएगा, लाइक द लेंथ ऑफ द रॉड इज गोइंग टू इंक्रीज. सो विद एवरी स्लाइस दैट यू आर एडिंग, द डिस्टेंस ऑफ दैट स्लाइस फ्रॉम द सेंटर इज इंक्रीजिंग. द फर्स्ट वन इज एट द सेंटर, द सेकंड वन इज स्लाइटली डिफरेंट, द थर्ड वन इज अ लिटिल बिट अहेड, फोर्थ वन इज बियॉन्ड दैट. So all of these, they are changing by dx, so dl is equal to dx. So we can write dm is equal to m by l dx. This is the first relation that we want, a relation between m and x. What is x? X is the distance from the axis. Now, what is the moment of inertia of that very small part? The moment of inertia of the entire rod is I. What is the moment of inertia of that very small part? Di. So di कितना होगा? It will be equal to m of the ith element multiplied by the distance of the ith element squared. So what is the mass of our element? The mass of our element is dm. So you will write dm. The distance of the element from the axis is equal to x. So you will write x squared. So you can write di is equal to x square. What is the value of dm? dm is equal to m by l dx. ये तुम्हारा moment of inertia का relation है. So this is di. di is equal to x square m by l dx. How will you find out the moment of inertia of the entire rod? The idea is you will add up the moment of inertia of all the small elements. Add up the I of all the small elements. I of each small element. So that kind of an addition is called as integration. तो हम लोग क्या करेंगे? We will basically integrate right now. So that is our third step. Our third step is to say that the net moment of inertia is the integration of di. The integration of di from where? From the left side to the right side. ठीक है, तो ये तुम्हारा ओरिजिन है. लेफ्ट साइड इज माइनस एल बाई टू, राइट साइड इज प्लस एल बाई टू. तो अपन कहाँ से कहाँ तक इंटीग्रेट करेंगे? यू विल बी इंटीग्रेटिंग फ्रॉम द लेफ्ट साइड विच इज एट माइनस एल बाई टू द राइट साइड विच इज एट प्लस एल बाई टू. सो द लिमिट ऑफ इंटीग्रेशन इज माइनस एल बाई टू लेफ्ट साइड एंड राइट साइड प्लस एल बाई टू. ठीक है, दोनों तरफ इंटीग्रेट करेंगे. वॉट आर यू गोइंग टू इंटीग्रेट? एम बाई एल एक्स स्क्वायर डी एक्स. I think you know how to integrate, but I'll still explain. M by L को बाहर निकाल लेते हैं because it's a constant. The integration of x to the power n, look at the right top side of the screen, the integration of x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. So what is n? N is equal to 2. So what will you have? X to the power 3 divided by 3. ठीक है, उस चीज को यहाँ पे लिखो. तो you will get x cube divided by 3. So this is x to the power 3 divided by 3. This is the value that you'll get. So next, what do? You will substitute the upper and the lower values one by one. So you'll write m divided by 3l. Now you put the upper value over here. So what is the upper value? The upper value is l by 2. What is the lower value? Minus l by 2. पहले upper वाला value को डालो. So you'll get l cube divided by 8. Minus. Put the lower value. So you'll get minus l cube divided by 8. So what is the total value you'll get? M divided by 3l, l cube by 8 plus l cube by 8, which is l cube divided by 4. This l will cancel with that l, you'll get square. So you'll get ml square divided by 12. So what is the moment of inertia of a rod? The moment of inertia of a rod is ml square divided by 12. That's the result that you should remember. This is the moment of inertia about the center of the rod or the center of mass of the rod. So whenever we find out the moment of inertia about the center of mass, we usually write it as I0. This is also written as I0. The moment of inertia about the center of mass of this rod is ml square divided by 12. So I suggest you try to do this on your own once. ठीक है, इसको pause करो अभी. Take a look at all the steps on the screen. I did not switch the page deliberately. So we started over here. The first thing that we did is that we took a very small slice. We called it a mass element. From that mass element, we found out the value of dm. So this entire step is step 1. Step 2, we wrote di is equal to mi/ri squared, and we wrote this relation over here. So that is your step 2. ठीक है, ये जो relation अपन ने यहाँ पे लिखा है, that is your step 2. And finally, the third thing to do was to integrate. The idea is to add all the moment of inertia of the small elements. That is your third step. You integrate it from the left limit to the right limit, and then you find out the answer, which is ml square by 12. समझ में आया? तो ये तुम्हारा मोमेंट ऑफ इनर्शिया है. The next class probably will start with moment of inertia of a ring and all the other objects. Instead of overloading you with more problems, let's just give you this much. To revise, go back. First of all, remember what's rotational motion. Rotational motion is different to translational motion. How? Translational motion, all parts of the object are moving in the same way. Rotational motion, different parts of the object are moving differently. So there is at least one part of the object that is at rest. That part is called as the axis of rotation. So in translational motion, when normally something is moving, you throw a ball, truck is moving, we have the idea of mass, half mv square, kinetic energy. Momentum is m into v. So in rotational motion, we have this concept of angular velocity, how something is rotating, how fast something is rotating. So the kinetic energy is written as half I omega square. So from there, we get the idea that I is equal to mr square. So what does this mean? Moment of inertia depends on mass. It also depends on perpendicular distance from the axis of rotation, which is r, distance from axis of rotation. So moment of inertia is not a constant quantity, it's a variable. If you change the axis of rotation, the moment of inertia of the same object is going to differ. I showed you a few problems, you can go back and see them. I also proved that the moment of inertia for the same system is different, the x-axis and the y-axis of rotation problem. And then for an extended object, what are extended objects? So objects that are not point objects are called as extended objects. So what do? We model an extended object as a collection of point objects. Okay, so we have all of these objects: rod, ring, disc, shell, cylinder hai, sphere hai, plate bhi hai. So all of these objects are modeled as a collection of point objects. How do we find out the moment of inertia? We use a three-step process. So what is our three-step process? The first step is to define a mass element. What is a mass element? A mass element is a very small part of an object. A very small part of an object is called as a mass element. We call it dm. Next step, you define distance from the axis of rotation. Distance from axis of rotation. इसको हम लोग define करते हैं. Distance from axis of rotation. Let's say we call it as x. And then we write di is equal to x square dm. Okay? For the mass element, you write the moment of inertia for the mass element. What is the third step? You define the limits of the integration. इसका limit define करो and then you integrate. इस चीज को इंटीग्रेट करो टू फाइंड आउट द टोटल मोमेंट ऑफ इनर्शिया. सो आई इज इक्वल टू इंटीग्रेशन ऑफ डी आई विच इज इक्वल टू इंटीग्रेशन ऑफ एक्स स्क्वायर डी एम फ्रॉम वन लिमिट टू द अदर लिमिट. ठीक है, तो ऐसे अपन मोमेंट ऑफ इनर्शिया निकालते हैं. सी यू इन द नेक्स्ट क्लास.